In section 1.6, we're going to only look at scientific notation, so we can omit the very first couple of problems, and let's move on to page 22 in your learning guide, starting with 2A. And always remember that videos that are on these solved problems are located in the multimedia library, and just click on the section that you're looking at and you'll have several more videos worked out for you. Alright, so let's look at 2A. Now when we deal with scientific notation, one thing that you'll want to remember is that if I have a positive exponent here, that's going to indicate that my number will end up being a very large number. So just don't get confused in the direction that you might move the decimal place. Positive exponent means the result will end up being large. Okay, so if I have 8 times 10 to the 7th, I start out with 8. Now 8 begins with the decimal place directly beside it to the right. If I'm going to move that 7 decimal places, I go 1, 2, 3, 4, 5, 6, 7, and then fill in every place with a 0. Then I end up with, and let's go back in and put some commas so we can see what this number actually is. But I've got a comma there, so it looks like that 8 times 10 to the 7th is the same thing as 80 million. Okay, and then 2B actually here has a negative exponent. So when we finish writing this in just decimal notation, I should have a very small number. Okay, so if I go ahead and write out the 7.86, if I moved it to the right, it would leave me with a large number. Negative exponent is going to tell me to move to the left, which results in a very small number. So I'm going to move the decimal place 4 places to the left. 1, 2, 3 zeros. So I end up with 0.000786 in decimal notation. Okay. Now let's look at 3A, where we're going to go in the reverse direction. I'm going to write this number in scientific notation. So we see that it would have a decimal place or an understood decimal place here. Scientific notation, I want the number, the first number to be between 1 and 10, but we're not going to include 10. So the largest I could get would be like 9.999, as many digits out as I could go. So I want to move my decimal place, I want it to end up right here behind the 2, the first 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 places to get it there. So 2.2 times 10. Now I moved 8 places, and remember this began as a very large number, so I should have a positive exponent there. Okay. Go to 3B. When I write this in scientific notation, this began a very small number, so I should have a negative exponent on the 10. Okay, and I want my decimal to end up right here behind the 2. So 1, 2, 3, 4, 5, 6 places. I'd get 2.93 times 10. It was 6 places, but remember this began as a very small number. So 10 times 10 to the negative 6 power. Okay. And then you won't have many, really, if any of these, but I do want to show you what happens with 2100 times 10 to the negative 9th. This is not in scientific notation because of this part. So if I were to write that part in scientific notation, I would have 2.1. Remember this started here, so I'd go 1, 2, 3 decimal places to the left, but that's a large number. So this was 2.1 times 10 to the 3rd, and then we have this already in there times 10 to the negative 9th. So this would end up as 2.1, and if we take 10 to the 3rd and 10 to the negative 9, add their exponents, I end up with 10 to the negative 6 power. Okay. The rest of the section, at least the learning guide problems, are omitted, and so that should be enough examples for you for this section.